lot of stuff that's going to involve fractions here in this chapter, and a lot of operations that are involved with it. You're going to hear a lot of things in this section about rational numbers, okay? The word rational right here is simply going to mean that you can write a number as a fraction, all right? So if you ever hear me say the word rational, rational is some kind of number that can be written as a fraction, okay? So our goal today is to look at writing fractions as decimals and then vice versa, turning decimals back into fractions, okay? So I don't doubt that you know what a fraction is. I mean, I would say, yep, I already know what a fraction is. I mean, I would say, yep, I already know what a decimal is, okay? So we want to go ahead and kind of make a connection between how decimals and how they relate to what we call rational numbers, or in other words, fractions, right? How do decimals relate to fractions as it talks about this idea of rational numbers here. Hold on a second. So goal-wise, that's where we're at. Write fractions as decimals and vice versa. All right, a little bit of vocab here quickly. First of all, rational number. Volunteer to read that first one for me. Volunteer to read that first one for me. Go, John.
Rational number.
Okay.
Any number that can be written as a fraction.
Okay, any number that I can write as a fraction. Okay. And I'll show you what some examples look like here in a second, but any number that can be written as a fraction is considered rational. Okay? Then, we've got this idea of two different types of decimals. One of them's called a terminating decimal. Okay? How appropriate. I watched Terminator 2 last night when I got home.
Nice.
Great movie. Nice! Do it again. Who said that?
Nice.
That's pretty good.
I'll be back.
That's pretty good. I like
I'll
that.
be back.
I watched The Grinch.
Gito
That's
di
good
Chapter.
too. Okay.
Speaking of which, I went to my cousin Jesse's concert up at Gallagher Blue Door a few days ago, and they sang the grit. They sang the
You're a
Grinch.
mean one.
You should have parsed.
Oh, that was good.
You're a mean one.
Okay.
Mr. Grinch.
Yeah, terminating decimal right here. How about a volunteer to read what this is?
Anna wants to read that.
Go, Anna.
Decimal that has a final digit.
It's a decimal that has a final digit. So basically, that last digit is the end of it. All right? And we'll talk about what that means here in a second. What's it say about repeating decimal?
Mason knows.
A decimal that...
A decimal that repeats.
Thanks, Mason. Okay. Hey, just real quickly, I want to show you the difference between repeating and terminating. So, first of all, guys, if you ever have fractions, what operation is really happening between the numerator and the denominator? If I had a fraction, say, what operation? Addition, subtraction, multiplication, division. Division is really happening here, right? So any fraction is really division. Numerator divided by denominator, right? So if I went something like 3 divided by 4, isn't 3 divided by 4 a fraction 3/4?
Yeah.
And I turn it to a decimal by dividing right here, I get 0.75. Now does this have a final digit in my window right here?
Yes.
Sure.
It does. And what is that final digit?
5.
So is that 0.75 going to be a decimal that we would say terminates or repeats right there?
Terminates.
Terminates. It ends right at 5. Now, something that repeats is probably going to do what to this window?
Just it's gonna keep on going and it's gonna
Okay.
have
There will be a final digit in my window, but it's probably going to fill that window completely up, right? Let me show you a couple of examples, and I want to kind of clear you up on some misconceptions that kids have about repeating decimals. If I would do something like, say, 3 divided by 9, what's that appear to be?
that would be
0.3 repeating, right?
Yeah.
Okay. Now there's a lot of 3's up there, but there is a final digit in my window of 3, right? Well, what do you think is really going on here?
It'll keep on going.
It's going to continue on forever, okay? So what kind of a decimal are you going to say this is?
That would be repeating.
It would be a repeating decimal, but you would say 0.3 repeating is what that decimal is. Now I want to show you the difference between something like 3/9 and 6/9. Your calculator's smart enough to do the following. First one was all 3's, right? How about this window right here? What's this end with?
0.67.
Okay, it was a bunch of 6's all the way up to this last digit, and then it put a 7 here. What the heck is going on there?
That's
It
the
rounds it.
terminating number.
Okay, is that 7 really correct or is it incorrect?
It's incorrect.
What's it doing again, John?
rounding
It's
it.
rounding that last digit for us, okay? So if you see anything that's really long like this, forget that last digit, okay? Really, this is a repeating decimal of just a bunch of sixes, alright? Sometimes I get people that'll turn this in and say it terminates at 7. Well, you understand that that 7 and that last part's being rounded, right? So this is really still a bunch of sixes that continue all the way through here, okay? Understand the difference? Good on the difference between terminating and repeating decimals?
Yeah.
Alright. Well, let's see if we can identify some things right here. Our first example is to say, hey, I want you to identify rational numbers. And we identify rational numbers by showing that they are some kind of, when I say write as a quotient of two integers right here, gang, all this simply means is write as a, let's see, quotient, what operation is that again? If I say the quotient of two numbers, it's division, it's a fraction, right? We're saying write as a, what here?
Fraction.
Okay, here we go. First things first. The directions say that show that the number is rational by writing it as a fraction. That means that these numbers up there that I've already given you are already rational. The first number I've given you is 3. Okay? How could you rewrite 3 in fraction form? 3 over 1. Yeah, dividing by 1. Isn't 3 divided by 1 the same as 3?
Yeah.
So 3 is fractional, 3 is rational simply because I can write 3 as a fraction in the form 3 divided by 1. How about negative 12? Why is negative 12 rational?
Because it converts to negative.
Well,
Because it's a fraction.
It's a lonely number.
it's a what number?
Lonely later.
Lonely number.
But it has a negative to keep him company.
Yeah, but I think we're missing the point here. We're trying to show numbers are rational by rewriting them as a what, gang?
Fraction.
Fraction. How do you rewrite negative 12 as a fraction to show that it's rational?
Negative 12.
Negative 12 over?
1.
Okay, negative 12 over 1. Now this next one, I don't like the way the next one's written, but this is some kind of a mixed number, 4 and 2/3. 4 and 2/3 is considered rational. Now guys, I know that you've talked about this before. Does anybody recall how to turn mixed numbers into what we would consider an improper fraction? What do you think, Lily?
Don't you times 3 and 4 together and then add 2?
So the denominator times the whole part, 3 times 4, and then add the 2. So I'm going to go 3 times 4, which is what value? 12 plus this numerator of 2 would be 14. And then what's the denominator going to be? 14 over 3. Now how do I know that those are the two exact same values? Well, here's the deal. You have a whole part of 4 right here plus a part 2/3, right? So let me show you something in the calculator. Do you agree that 4 and 2/3 is really 4 plus 2/3, guys?
Yeah.
Okay. So watch what I do here. I'm going to take 2 and divide it by 3 first. Okay? What decimal do I get?
6.
0.6 repeating, right? And then what whole value would I add to that 2/3 to turn this to a definite decimal? Well, I would add 4, wouldn't you? So when I divide this out, 2/3, and then add that whole value of 4, isn't this in decimal form 4.6 repeating?
Yes.
Okay. Then, if 4 and 2/3 is written in fraction form as 14 over 3, 14 divided by 3 had better be what? 14 divided by 3 had better be the same as 4 and 2/3. So what had I better get out of the calculator when I type in 14 divided by 3?
It is the same answer.
Same thing. So let's check that. Let's confirm this. How about it? Do we get the same thing?
Yes.
Okay, so do you understand how to take a mixed number, a whole part and a fraction, and turn that into just an improper fraction? Okay, now the next one's a little trickier. Notice what kind of a value do you have here?
Negative.
It's a negative mixed number. Don't let the negative fool you on this, okay? What I'm going to tell you to do is this. Work with the part that is, why is that doing that today?
Lovely.
Lovely. Just block it out.
Lovely
block it out.
colors right there.
Oh, come on. John Deere green, I agree.
No.
You ease down. I know what you're getting at. Stop it. You're naughty. All right?
Wait, what? Packers?
Don't use that kind of language in my room.
I don't even like
Don't you dare use that kind of language in my
I
room.
don't
Okay?
like football.
All right. deal with the part that's the improper fraction first, and then at the very end, throw your negative back into it, okay? So the 2 1/4 part is what I'm telling you to look at first, okay? So 2 1/4, how about 2 1/4 as an improper? What would that be? What over what? Right here.
1, 2, and 1/4.
Okay, 2 1/4. How do I turn that into an improper?
Oh.
Same way Lily did.
Times 2 plus 1.
So what over what?
9 over 4.
Yep, 4 times 2 is 8. 8 plus 1 gets you a new numerator of 9. How about my 9 over 4? And where's your negative sign going to go? Well, it doesn't really matter. I always put mine up top, okay? So negative 2 1/4 is written in fraction form as negative 9 over 4. Tying this all together, why are the 4 numbers that I gave you in A, B, C, and D considered rational numbers? Why are the numbers, why are the numbers in parts A, B, C, D in example 1? Why are these rational?
Because it right as a fraction.
We have written them as a,
Fraction.
that's exactly what it means to have a rational number. You can write them as a fraction. Okay? All right, guys, next one is the simplest thing in the world. We've talked about this already, so it shouldn't take too long. Example 2 is simply writing fractions as decimals. So any fraction, turn it to a decimal. What are you going to do with 5/16 to turn it to a
You
decimal?
write them and you get 0.01953.
We better check that. We better check that.
I got 0.3125.
0.3125?
Yeah.
Let's check
My
it. We're-
calculator must have been
5 divided by 16. Yep,
Yeah, mine
0.3125. You guys agree there?
Yep.
5/16 as a decimal. Just divide the numerator by the denominator. 0.3125. By the way, is this a repeating decimal or a terminating decimal? Terminates. It ends at the 5. Was anything even repeating up here? I'll put a T back here just to get you to understand that terminates. Okay. Next one is 4 divided by
9.
9. Okay. 4 divided by 9. Anybody got it yet?
0.444444, so on.
A lot of 4s, right?
Yeah.
How do I express that? How do I
4
express
with the
that?
bar, 0.4 with the bar on top.
Of which value?
4.
Okay, so bar notation right here. If I put a bar just above the 4, that indicates to me that the 4s go on forever.
Oh.
Hey, I got a question here. This is a repeating decimal, right?
Yes.
Can repeating decimals be expressed as fractions?
No.
Didn't this repeating decimal come from a fraction 4 over 9?
Yes.
So the question is, can a repeating decimal be a fraction? So that means repeating decimals are what kind of number? Starts with an R. Rational. Terminating decimals are also what kind of number? Rational. Okay, I'm going to put an R down here for repeats, but any decimal that either terminates or repeats is considered rational. Right? So, questions on the first side at all? Anybody?
No.
Understand how to turn a number into a fraction to represent a value as rational? Good with that part?
Yes.
Understand how to take a fraction and turn it to a decimal?
No.
No.
This is no.
Yeah.
Oh, I thought I said no.
Yeah, no.
All right. Well, here's what I'm going to ask you guys to do. I would like you on your own to go ahead and write those fractions in 1, 2, 3, and 4 as a decimal.
Done.
Take a second, punch them up, see if you agree, okay, kiddos? Where's that grade sheet at? Who's had that? You took it. Did I take it? Here's a better question. Where did I set it down at, Kyle?
There, probably.
There it is. Might need more time with those.
I do.
Just divide them out, right, Johnny?
Yes.
Okay.
What you doing?
There it is. All right, 7 over 20. What'd you guys get?
Point 35.
Negative 0.6.
Negative
0.6 for number 2.
negative
and then number
0.6. So
3,
some you might just call it negative 0.6, either or.
8.48.
I kind of messed this up. This should be, I want to talk about this one. This is really 2 and 12/25, right, guys? How many of you guys punched in 212 divided by 25? And you said negative, I'm sorry, 8.48.
Yeah.
I agree with that. This is kind of a bad problem. What I'm getting at here is this. In a mixed number like this, I guess that, do you guys kind of see the space right here between 2 and 12?
Not really.
Okay, well, how about
After.
that? After the fact, right? Okay, so you guys agree that this can be a mixed number. I'll do a better job of typing them up for you, but I guess that what I really want to talk about mixed numbers, look at the fraction part first. I'm just going to go what divided by what?
12 divided.
12 divided by
Times
25.
2.
Okay, whoops. 12 divided by 25. That gets me a decimal of 0.48, right?
Times 2.
But not times 2. This is really 2 plus how much more? 12/25, right? So what am I going to add to the 0.48 part here? What
Plus
whole
2.
value? Okay.
So that'd be
So it should really be 2.48 here, right? Does that make sense? So in a mixed number, do the fraction part first. Like in this part, the 12 over 25 was at 0.48. And then add your whole value to it in the end. And in this case, 2.48. Okay, my last one, kiddos, 23 over 40. Yes, Brandon.
0.575.
0.575?
0.575.
Very good. I agree. Okay. How are we feeling about turning fractions to decimals? This might be the easiest thing we've done all year, right?
It's like a day thing.
Last try was easy too. Or not last try, last.
Just want me to put this on your desk.
Yes, please, Ken. Thank you. Okay. Right here, using decimals to compare fractions. We kind of talked about this when we were starting to look at least common denominator a little bit, didn't we? I want to know which fraction's bigger, 42 over 48 or 27 over 30. Well, the idea being here is that, you know what, if I turn stuff into into decimals, we should be able to easily compare it. So how do you turn 42 over 48 into a decimal, gang?
You divide those two,
Let's
you
go.
get
42 divided by
0.875.
48. What you got?
0.875.
0.875. What do you get for 27 over 30 when you punch that up?
0.9.
So 0.9, right? Okay. So 0.875, 0.9. Look at the first digit after the decimal point. Are they the same or different?
Different.
Which one's bigger, the 8 or the 9? So which fraction has to be bigger, the one on the left or the one on the right?
Right.
Well, on the right. So I'm going to say this. Since this decimal 0.875 is less than 0.9, I would say that the fraction 42 over 48 is less than the fraction 27 over 30. Okay? So anytime you're doing comparing, and this is kind of what we alluded to at the end of chapter 4, just turn your fractions into a decimal and then make a comparison. Okay, can we handle that part?
Yes.
Okay. So maybe the two parts here that are probably most important for us today are being able to convert decimals back into a fraction. You've gone from a fraction to a decimal simply by dividing, right? So part of our goal was to do that, and then vice versa. Go from your decimals back into a fraction. Now I'm going to give you some shortcuts today. Because we said, what types of decimals would be considered rational?
Terminating.
A repeating and a terminating one,
Yes.
right? This part right here, highlight it, star it, exclamation point it. Just make sure.
Alright.
I gotta change these color schemes.
Highlight.
Those are perfect.
And
You
I'm
settle down,
highlights.
Metzger.
Slide it up.
Little black gold. Go Hawkeyes tonight. Beat them Cyclones, right?
Yeah.
Beat State. Right?
We're gonna
That
lose.
is tonight, isn't it?
We're gonna lose anyway.
I wish you and I was still
All right. We beat the Denver
Where's
Cyclones tonight
example
too, right?
6?
Writing terminating decimals as fractions. Here we go. Guys, what kind of decimal am I working with to start with?
terminating that.
Okay. I want you to write this note up here. I'm going to put a 1 and then I'm going to put the word zeros back here. 1 and then some zeros, okay? In fact, I'm going to use one of our decimals that we had. Okay, here's what I'm going to do. I want you to change 0.35, and I want you to write this as a fraction. Now listen to me in this. Fraction, and this is the part where it's going to get tricky. Fraction in simplest form. Okay, here's how this works. Guys, first of all, 0.35, terminating or repeating?
Terminating.
Terminating. 5 is the last digit, right?
Mhm.
This is a question you ask yourself about terminating decimals. How many digits are there after the decimal point?
Two.
There's 2 of them, right?
Yeah.
So what you're going to do is you're going to take this value, get rid of your decimal point. You're going to put 35 over, okay, what was the kind of trick I put up here? 1 and then what?
Zero.
Zeros, okay? You're going to put a 1 down here. Now remember that question I said or asked? How many digits were after the decimal point up there?
You put 2 zeros behind it.
There were 2 digits up there after the decimal point. So I'm going to put 2 zeros after the 1. Okay, now just to show you why,
Divide by 100.
if I would take 35 and divide it by 100, whoops,
You get 0.3.
isn't that exactly what I started with? So I've taken 35 and I'm sorry, 0.35, or this is really red, it's 35 hundredths, because this is the 10th place and this is the hundredths place. And I'm sure you've talked about that an awful lot in science, right? Yes?
Yeah.
Yes.
Okay? So this is really red, it's 35 hundredths. Don't I have a fraction that says 35 over 100 or 35 hundredths right there like that? Agree?
Yes.
Okay. Now our job then is to write this in simplest form now. Okay? So look at the 35, look at the 100. Can you think of a nice number that would divide evenly?
Divide by
5.
5 will, right?
Yeah.
And in 5 and 0. How many times will 5?
7. 7.
Goes in here how many times? 7. How many times will 5 go into 100?
20.
20. Okay. Now look at your fraction 7 over 20. Can I go any further there?
Yeah. No.
Can't, can you? Can't go any further on 7 over 20. So how is 0.35 and or what's that going to look like in simplest form of a fraction? You would say 7 over what? 7 over 20, right? Okay. By the way, I stole that one from up top. What did we have?
10 over 20.
Which was 0.35. Understand how we work backwards from there to get to here?
Yeah.
Okay. Let's try another one. I'm going to make some room here quickly, so give me a second. Okay, kiddos, let's try this one. Let's go. How about point?
8.
How about 0.84?
Right. 8. 5.
You know what? Let's put another digit in there.
5.
Okay.
Right.
So this is going to become the following. This is going to be 845 over what, guys?
1,000.
Why 1,000 this time?
Because there's 3.
There were 3 digits after the decimal point up here, which implied how many zeros down here?
4, 3, 3. That is 3 times 4.
Okay. 3 zeros. 3 digits after the decimal point, so I gotta have 3 zeros down here. All right. Now again, this rule works for what type of decimal? Terminating. Very good. Could I reduce this?
Yeah.
Oh, yeah.
What's gonna go into them again nicely?
Tie.
5 will go into both of them. Boy, in the bottom, I know it goes in here 200 times. How about the top?
200.
Divide the top by 5.
Is it 169?
Which way?
169.
Is that right?
Yeah.
We divided by 5, right? So we divided both of these by 5, divided by 5 up here. Because that ends in 5. How much?
169.
Okay. How about 169 over 200? I don't think that can go any further. 8, no. That's as far as she goes right there. Now how can I know that that's right at least? Couldn't I at least take 169 divided by 200?
Yes.
And if I did that, what would my decimal be?
0.84.
Better be, right? John, are you checking for me?
Yes.
Is it 0.845?
Yes.
Okay. So what's simplest form of 0.845 here, kiddos?
Yes.
What?
What's simplest form of 0.845? 169 over 200. Now, I want to look at an example where you might have maybe a mixed number. So suppose you have something like 2.12, like this.
Is this
Okay?
on the next page?
You can put it right down here with your third example if you've got room. So start one with like 2.12. Now guys, the difference here is that there's a whole number out front, right?
Yeah.
Do the same exact thing. Just forget about the 2. What I want you guys to focus on is the 0.12 because what are you going to put out in front in the end? Okay. The 2, right? Okay, so just, well, you'll focus on 0.12. To turn 0.12 into a fraction, turn 0.12 into a fraction, that's the same as 12 over what, kiddos? 1, 2 zeros, right? All right, so let's reduce 12 over 100. 2 will go into both, right?
Yeah.
I've got a 6 and I've got a 50. And then won't 2 go into both of what I have here now, the 6 and the 50? How many times will 2 go into the 6? 3, won't it?
Oh,
How many times will 2 go into 50?
yeah.
25.
25 times. Let's see, can 3 over 25 be reduced now?
No.
So this 0.12 part after that whole number of 2 was what fraction, guys?
3 over 25.
So how am I going to turn 2.12 as a decimal into some kind of a mixed number now? 2 and 3/25. Okay. So if you ever have a number out in front of the decimal, do you need to worry about that?
Nope.
No, just worry about everything after the decimal. Turn your decimal to a fraction, but make sure you put your whole number back out in front and it's written as a mixed number when you're completed there. Okay? So terminating decimals to write as a fraction, what's kind of the shortcut I said?
What's a terminating decimal?
Terminating decimal means it has an ending decimal, like 2 would be the last value.
Okay.
I think it's got a last digit.
Okay.
1 and then some zeros was your rule, right?
Yes.
Okay. Now, guys, if you'll flip to the third page, we also said repeating decimals are rational, right?
Yeah.
Okay, I'm going to give you a rule for this one. You ready, the rule? Okay, for repeating decimal, I want you to think
I got
9.
you, Mr. Parson.
Okay, very good. Thanks, Mr. Slater.
Okay, bud.
Have a good weekend, bud. All right, writing repeating decimals as a fraction, kiddos.
90s?
Says think 9s.
Okay.
9s. All right, I'm not going to get into why this is the way it is, but I'm just going to tell you the shortcut on it. It's a repeating decimal to write as a fraction, think 9s. Guys, didn't we have like a bunch of 0.3? Didn't we have a 0.3 repeating at one point in our lesson already in the calculator? Okay, here's the deal. I'm going to do a couple of examples. So I'm going to split my paper like this. Okay, I'm just going to go 0.3 repeating. Okay, so here's how I'm going to do this. First of all, guys, in that first example, what digit's getting repeated over and over?
3.
The 3 is. Okay, So here's the deal. You're going to take the digit or the number of digits that are being repeated over and put it over the same number of 9. So in this case, there's only 1 3 getting repeated over and over and over, right? You guys agree there?
Yes.
So the bar is only going to be over 1 3, right? So you're going to take that and put 3 over what value? Well, 3 over 9. With me there?
Yes.
Okay. Now, can 3 over 9 be reduced?
Yes.
To what? 1/3. Let's just check. If I punch 1 divided by 3 in my calculator, it had better be what? If I go 1 divided by 3 in my calculator, what's that going to look like as a decimal?
It's gonna be 3.
0.3.
Point.
3 is repeating, right? Holy cows, we're right. Okay, repeating decimal. Use 1 and zeros or use 9s?
Use 9.
Use 9s. Okay, so let's trick you. What if I had point something like this, 0.45 repeating? Okay, it goes, if I put a bar over 4 and a 5, then that means it goes 0.45, 45, 45, 45, 45, 45, 45, 45, 45, 45, 45, 45, 45, 45, 45. Oh, there's a desk there, okay? Right?
Yeah.
How many digits are getting repeated in this mess right here?
2.
The value that's getting repeated is really a 45, right, guys?
Yeah.
How many digits are repeated?
2.
2. So how many 9s do you think I'm going to throw this one over as it's a repeating decimal?
99.
99!
99.
Okay, let's do it. Do it. Gotta simplify this, okay? 45 and 99. Hey, I know that 9 goes into both of those. 9 goes into both of those.
45.
How many times will 9 go into 45?
5 times.
5 times. How many times will 9 go into 99?
11.
So we think 5 over 11, if I would divide that out, might be what decimal?
0.45 repeating.
Oh my.
But
Hey.
Okay then.
You guys try this one. I'm going to try and trick you on this one.
oh no.
Listen.
No, not that. Anything but that. Please don't trick us. No.
How many digits are getting repeated over and over, guys?
3.
So you're going to put the 201 over what?
999.
201 over 999. Okay. I can't trick you guys. You're too smart. Hey, got a question. Can you guys think of any number that would divide evenly into those? Remember your rules?
Yes, 111 will go
3.
into 900.
Try 3. I know 3 because 2 and 1 add up to what value? 3.
Ugh.
Won't 3 go into 999 also? Because that adds up to 27. How many times will 3 go into 201? 37?
I can't see it.
We're dividing by 3's up here. By rules of 3
No.
that we've looked at in the past. How about 999?
67.
Oh, I'm sorry, 67. So this should be 67 over
333.
333. Let's see, 67, I'm pretty sure that's prime, isn't it?
Yeah.
So I can't go any further with this, can I?
No.
So let's check. Oh, dear
It
Lord.
is.
Please tell me that this is going to work.
It is. It will. I know.
Oh, my goodness gracious. It works, doesn't it?
Yes.
Next time,
Okay.
if we do this again, can we do a 4-digit number?
You can do a 16-digit number if you want to. That's a lot of 9s. Okay. Do you guys understand my shortcuts between terminating decimals and repeating decimals and how to put them back into some kind of a fraction in simplest form? Use the rules. You got to ask yourself a question: do I have a terminating decimal first, or do I have a repeating decimal first? Am I using a rule of 9s, or am I using a rule of zeros? Okay. Okay. This is how I remember it. You want to know how I remember it? Well, all the zeros are really a base of 10, right? Terminating decimals, think 10s. Terminating 10s. They both start with a what? T, right? Terminating 10s. All right. Okay, well, I think what I'd like to do here, you know, I think we're pretty good on this. Write each fraction as a decimal. I'm sorry, write each decimal as a fraction. 0.8, you would put 0.8 over what, guys? 0.8 over not 1, but 1 and how many zeros?
10.
I'm sorry, I'm gonna back up. I'm messing this up completely. This will
1
become
zero.
8. 8 over what?
10.
10. Okay, can that reduce?
Yeah.
Can that reduce to what, gang?
4/5.
4/5. Okay. If I had the 0.12 repeating like that, put a bar above the 0.12, and I'm not going to go very much further on this. I'm just going to write the answers down here quickly because I want you to get your quick quiz done. I would really put 12 over what this time since it's repeating?
12 over 99.
12 over 99. Since it's a repeater, 2 digits over 99, and then reduce. 3 will go into both of those. Okay, 3 goes into both of those. Up top, 4 times. On the bottom, 33 times. And the nice thing about all these problems is this. Once you get a fraction, can't you divide that fraction out to see if it matches your starting decimal?
Yeah.
So is there any excuse really to miss any of these? No, not at all. Okay. All right, is 4 over 33 working out, gang? Anybody that divided that out? Did you get 0.12 repeating?
It is.
It is? Okay. Guys, last thing that I want to talk about, order the following. If I had something like this, 0.75, maybe, I don't know, 3 divided by 5 and 2/3 like this. We talked about this a little bit in the last chapter. We said if we're going to order these from least to greatest, turn everything into a what?
Fraction.
Turn everything not into a fraction, but turn everything into a,
Decimal.
first one's already a decimal, isn't it?
Yes.
Okay. So I've got this 0.75 here. How do you turn 3/5 into a decimal? How do you turn 3/5 into a decimal? How do I turn that to a decimal, guys?
Take 3
Just divide it. 3 divided by 5. What have you got?
0.6.
Okay, and then finally 2/3. What's 2 divided by 3 getting you? What do you guys get when you punch 2/3 in?
Oh,
0.6 repeating.
Okay. Guys, what's the smallest decimal up there?
0.6.
0.6. So what's that mean the smallest number is going to be? That was given. Wouldn't 3/5 be my smallest value?
Yes.
Okay, what's the next smallest value then? Isn't that
0.6
0.66 or 0.6 repeating? And then my last value is 0.75. So my order is going to go 3/5. That was the smallest decimal. After that, we're going to have 2/3. And then finally, the largest value is going to be what that was given? 0.75. So guys, anytime you're ordering something, always turn stuff to what?
Decimal.
Always turn stuff to decimals. Okay. All right. Remember, your book page not due until when?
Tuesday.
Tuesday. 1 through 41, every other odd, page 222. I believe the quick quiz is attached. Is that right?
No.